Both live and studio sound, signals are manipulated in order to improve different aspects of the sound wave. This is done using signal processors. This video will look at one of the two main types of processors, compressors, the other main type being equalizers. These processors control two of the parameters of a sound wave. Equalizers control frequency and compressors control amplitude. As well as being useful on their own, they are the basis for a number of other processors, including gates, duckers and limiters. The two can also be combined to create multiband compressors and de-essers. This video will look in detail at the theory behind compressors. The idea of compression is to reduce the dynamic range of a signal. This is defined as the difference between the lowest and highest levels in a signal. There are a few reasons for the need to compress. It can be used to reduce the dynamic range of a track, limiting the volume of a channel, or to shape the sound of a specific instrument or mix. The human ear perceives louder music as sounding better. By reducing the dynamic range of a signal, the gain of the whole track can be increased further before clipping occurs. Although the peak level is still the same, overall it will appear louder and therefore more appealing. By adding compression to a channel, the level of any audio coming in can be limited. This is especially useful in a live sound environment where a performer may be unpredictable. The compressor can be set to compress at a certain level, meaning that any signal above this level will be significantly reduced. This will remove the possibility of audio peaking and will also protect equipment. An uneven signal such as a vocal track or a drum, which has a large dynamic range, can be levelled out to help it sit within a song. Without this, the quiet parts would be drowned out and louder parts would seem overpowering. Using a compressor, the dynamics of a signal can be altered, allowing it to be shaped. An example of this is in mixing drums. Compressing parts of a drum mix can help balance a mix. For example, compressing a kick drum, but leaving the very start uncompressed will help it to cut through the mix, but the compression after the initial peak will help it not to overpower the other drums. Compression is achieved by squashing the peaks of a sound wave in order to reduce the amplitude. This is done using two main parameters. The threshold determines the level at which the compressor will start to compress the signal. The ratio controls how much the signal is compressed by once it exceeds the threshold. This diagram shows the input level against the output level of a compressor with no compression applied. The output level is directly proportional to the input level. When compression is introduced, a threshold is put in place, shown by the black dotted horizontal line. Anything above this level will be affected by the compressor. A ratio of 1:1 would mean that for every 1 decibel over the threshold that goes in, 1 decibel would come out. The signal would be unchanged. A ratio of 2:1 is shown by the purple dotted line. For every 2 decibels above the threshold that goes in, 1 decibel will come out. This effectively halves the level above the threshold. With a ratio of 4:1, for every 4 decibels above the threshold that goes in, 1 decibel will come out. A ratio of infinity to 1 means that nothing can go above the threshold. This would be a brick wall filter and would sound very unnatural. In reality, a ratio of 10:1 or higher effectively sets the threshold as a limit. The higher the ratio is, the harsher the compression becomes, and therefore the more unnatural it will sound. Before compressors were designed, an engineer would have to ride the gain of a signal, reducing it during a peak and increasing it during quiet sections. An analog compressor is effectively an automatic gain control. To do this, a compressor has two main components: the compression unit, which would be the gain control, and a sidechain, which would be the engineer. The sidechain listens to the signal and tells the compressor when a peak occurs above the set threshold. The compressor can then compress the signal according to the chosen ratio. A simple compressor could be based on a voltage-controlled amplifier. The audio goes into the VCA and a copy is sent out to the sidechain. The sidechain analyses this and creates a signal to tell the compressor when the threshold is breached. The VCA adjusts the gain accordingly and a new signal with a smaller dynamic range is created. As well as the threshold and ratio controls, a compressor has a number of other parameters that can be altered. The first of these is the attack. This is the time taken for a compressor to respond to a signal that exceeds the threshold. A short attack time will mean that the compression will kick in as soon as the level exceeds the threshold, and the whole signal will be compressed. A longer attack time will mean that the compressor will take longer to kick in, therefore the very start of the signal will be uncompressed. This is especially useful with drums. The very start of the sound is what allows it to punch through the mix. By allowing the very beginning of the sound to be uncompressed, the drum will still be able to punch through, while the rest of the sound is compressed, allowing for other sounds to be more dominant. The second of these extra parameters is the release. This is the time taken for the gain level to recover back to normal after compression has been applied. A quick release time will mean that compression will stop very quickly after the level falls below the threshold, and the gain will recover quickly. A long release time means that the compression slowly releases. This can help the compression to blend in and not be audible. However, if the release time is too long, the gain may not have recovered before the next sound that needs compressing. This will cause the following sound to be overcompressed. The knee of a compressor describes the transition into compression. This can be seen in the compressor on screen. As the knee is increased, the line in the compressor graph becomes a curve. A hard knee means that as soon as any level passes the threshold, it will be instantly compressed. This can cause an audible change when compression kicks in. Softening creates a curve in the graph. The compression is slowly introduced as the level increases, creating a smooth transition between uncompressed and compressed audio. The fifth and final control is the makeup gain. Once the signal is compressed, the dynamic range of the signal will be reduced, and the overall peak level of the signal will be lower. The makeup gain is used to boost the level back up. This video has covered the basics of compression under compressor. Part 2 will look at some of the clever ways a compressor can be used, including sidechain and multiband compression.